Hello, my dear students. Today we are in lecture number 35. It is lecture 35 of chapter 3, current electricity. I am B.S. Pandey. My dear student, last class we have finished with the temperature dependency of resistivity and resistance. Today we'll discuss the limitation of Ohm's law. Till what extent Ohm's law whether it is applicable. So we'll study the limitation of Ohm's law, my dear student, today. It is the limitation of Ohm's law. Okay, so we are going to discuss here the limitation. Remember Ohm's law. As you have studied the Ohm's law and you are having the concept of Ohm's law, the V directly proportional to I, and that is only for the ohmic conductor we talk about. Okay, Ohm's law valid for ohmic conductor, and ohmic conductor are those for which VI graph is found to be straight line and passing through origin. Remember, actually this is applicable for the ohmic conductor. For ohmic, and you will ask, what is ohmic conductor, sir? So all the conductors, the metal that obey the Ohm's law, that are considered the ohmic conductor, and also they give their nature as a straight line, that is the VI characteristics, a straight line you will find, and it is also passing through. This is the ohmic conductor for ohmic conductor. Remember students, if it is not passing through the origin, then it is not that it is not obeying the Ohm's law, but that might be it has not the perfect characteristics of ohmic conductor. Okay, so the first we know that the ohmic conductor, and that show the nature of this one, like if it is current, it is voltage, then ohmic conductor show the graph of like this one. But in all non-ohmic conductors, okay, non-ohmic conductors, that is the non-ohmic circuits, you can consider few points that will be considered as the limitations, you can say. Okay, so the following points come in notice, you have to be bear in your mind. Following points will tell you about the limitations of Ohm's law. And what is that? So the first point, it is non-linear dependence of VI characteristics. Remember, non-linear dependence, okay, non-linear dependence of what? Of VI graph. This is the first limitation. The conductor will not show the non-linear dependence, B. That is the second. For same value of voltage, the graph, okay, for same value of voltage, like I am drawing the graph this way. What is actually I am going to draw here, for same value of V, the graph of VI depends upon the sign, okay, sign of what? Voltage. If it is voltage and it is current, then you can see it is straight line, but here it is changing like this one. It means the sign here, the positive, in positive direction we are giving the voltage, and here in negative direction. It means for same value of V, the graph of VI graph depend upon the sign of V, that is the nature of voltage. Okay, and the third point, regarding the limitation of Ohm's law, it is, and the last point, if you will draw the graph of gallium arsenide, which is a semiconductor, for gallium arsenide, this is semiconductor, remember my dear students, it is semiconductor. Okay, if you will draw the graph, you will find like this way. This graph looks like this one, more or less. This is the current and this is the voltage, and this graph shows like this one. Here you can see, if you draw a parallel line to the voltage, you will find here the two value of V, like V1 and V2 for one value of current, okay, which is not possible for the ohmic conductor and which is not applicable. If it is showing this such type of graph, it is not obeying the Ohm's law. So we may have more than one value, okay, this voltage may have more than one value for same value of current, okay. So this will be the limitations of Ohm's law, my dear student, okay, and the few more you can study in NCERT in detail. Okay, now we should move to the next topic, my dear student. So we'll study right now the color coded carbon resistance, my dear student, or the color coded carbon resistance. In last class I have shown a circuit, if you remember, not in last class actually, in the lecture of capacitance. There was a capacitor in that circuit also. Right now I'm not having around me, but I'll try to show in few lecture after few lecture that the resistance. Now we are going to study here the color coded carbon resistance. Our topic will be the color coded carbon resistance. Color coded carbon resistance, okay. My dear student, for commercial purpose, remember, for commercial purpose, high resistance, okay, in kilo ohms, high resistance are made up of carbon, okay. This is the carbon resistance. So for the commercial purpose, we used to make the high resistance with the carbon. The value of resistance can be decoded by the color code on resistors given. Electricians actually read the color code and they give you, if you go to the electric shop and you will ask, kindly give me a resistance of 50 kilo ohm, then it will not written over the resistor like 50 ohm, because that is a very small device, but that electrician will read the 50 ohm. Yes, this is the 50 ohm, and you will ask how you can read, then he will show you using the multimeter that yes, it is showing 50 kilo ohm, you can take, but I cannot teach you, okay, that will tell you. But here we will study how to read the color code. It is given over the resistor. Suppose it is the structure of resistor, the two terminal, four rings, it is four rings are designed, four rings, 1, the 2, the 3 and the 4. Minimum 3 rings will be there. Remember students, it is not necessary the 4th ring will be also available, but minimum 3 rings will be there. If 4th ring not there, then that will be the no color, and all the rings having the different color, it might be, okay, all the rings will have the different color, it might be. And then you will have to study the resistance of this particular resistor using that color code only. Remember, this particular first ring is considered as the significant figure 1. The second one is called the significant figure 2. Third one is called the multiplier, and fourth one is called the tolerance. Okay, these are the two terminal of resistor X and Y, you can say. Now what does it mean of the 4 rings? So here the ring 1 will give you, okay, first ring, it is the first significant figure. What does it mean, sir? If you're writing 20, then first significant figure will be 2 and the second will be 0. Okay. The second ring give you the second significant figure. Now the third ring will give you the multiplier. Okay. This is the third ring will give you the multiplier. And the fourth ring, remember this multiplier, you will get, it is in power of 10, my dear student, in power of 10. Okay, like 10 to power 2, 10 power 3, 10 power 0, 10 power 9, 10 power 8, etc. Okay, now the fourth ring will give you tolerance, and this will be in percentage. Okay, 5% tolerance. What does it mean by the tolerance? Suppose you have made a resistor of 100 ohm, then you know that the resistance of any resistor can vary. It depends upon the temperature. If you have made the resistor in laboratory, it is at 40 degrees Celsius, and you have to use that particular resistor in your home, in a household circuit at 20 degrees Celsius, then you must have to give the reading that how much it will increase or decrease. That is on the temperature. That's why we use here the tolerance. Yes, this resistor can tolerate maximum this temperature, can tolerate minimum that temperature, and I'm giving you the range. Okay, that's range actually is considered as the tolerance. That this percent, it is 5 to 20%, it is given in your NCERT book. Okay, how it will be, we will study. But overall, you have to write the resistance in this way. The formula of resistance will be R is equals to, this is very important, significant figure 1, significant figure 2, then multiply to the multiplier plus minus tolerance. And very simple, this is the ohm, that is the resistance. I don't think so. This is a very difficult to remember. S1, S2, and then multiply M, and then tolerance in percent, my dear student. But to write the value of S1, S2, M, and tolerance, you must have to remember a table. From there, you will find the value of this color. Okay. So my dears, kindly note down this one, because I need to erase this one. That table will be little longer. Here, S1, S2, multiplier, and tolerance in percent, my dear student. Okay, so you have to remember this table. To remember this table, there are a number of slogans have been made in your NCERT also. I think not NCERT, but in few books it is mentioned. BB Roy of Great Britain, America, blah blah. I'm giving you a different funny slogan that could be easy for you to remember. Look at here. This is the black beer. I'm giving you the black beer. Black beer roasts our young guts, but vodka goes well. Okay. So this one is the slogan, student. You can remember the value of the first letter is only in the slogan matters. That is the B. Thus B, R, O, Y, G, B, V, G, and W. Okay, my dear student. Now I'm writing the color using this slogan. Here I will give you the color, and then in this two line the significant figure S1, S2. Okay, here the color, here the S1, S2, here the multiplier, And the last one will be the tolerance. That will be the another 3 different colors. So here the B stands for black itself. Okay. B stands for brown. Don't confuse with the 3 B's are there. Okay. This will be the blue. You can see this one is the darkest one, sorry, deepest one, then moderate one, and then this is the light one. R, red. Black, beer, rose. O, orange. Y, yellow. Z, green. V, violet. Z, gray. White. Okay, now we'll give the value. It is very easy. It is very easy. You have to give the values from 0. Okay, 1, like counting. A third class student can do. 2, 3, 4, 5, 6, 7, 8, and 9. You will not get the number after 9. And the significant figure, actually you will use the S1 S2 from this, the same. This is also the 0, 1, 2, and so on. Okay. Now multiplier. The multiplier you will use here 10 to the power 0. You have to just only put in the 10 to the power 1, 10 power 2, 3, 10 power 4. I hope you got here the 10 power 2, 10 power 3, 10 power 4, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 to the power 8, 10 to the power 9. Now the tolerance. There will be the 3 tolerance in this particular, that is, you have to, the 3 colors. The first one, it is gold. Then second is the silver. And the third one is the no color. Okay, no color. For gold, we use tolerance 5%, silver 10%. You have to double, just double 5 to 10, 10 to 20. It is. So this is the entire table. You must write this particular table, and then after we will able to write the resistance of, okay, few. I'm giving you the example, and you will be able to write the resistance. Okay, my dear student. So may I rub this one, and then after you will write the resistance. Okay, I'm not rubbing, I'm writing here the example. Okay, let me rub this one. The one example I'm giving you, my dear student, you have to find the resistance, okay, and you have to match whether your answer is correct or not. You have to write the resistance of this one, the first ring, second ring, third ring, and fourth ring. The first ring, suppose it is yellow. The second ring, suppose it is red. And the third, it is blue. And the fourth one is gold. Okay. Can you find out the resistance of this resistor? I'm writing the answer, and try to find out and match your answer, my dear student. So it is R is equals to, you have to write first the tolerance. Which color? Yellow. Find out the yellow. It is yellow, and the significant is 4. The second significant is red. Find out the red. It is 2. So the 42 into. Now you have to write the multiplier. The black. The black multiplier is 10 to the power 0. How much? It is 1. Plus or minus. Okay. In formula I have written plus, but there will be the plus or minus. Okay. Now the tolerance. Gold. How much? 5%. So you can write the resistance like this one. The range of resistance will be how much? If you will try to write the range of this resistance, you will write it is the 42 plus 5% of 42 or 42 minus 45% of 42%. So this is the range. So this will be the answer. Now the next one, try to write the answer now. How quick you can write the answer. Let me see. This one, the green, red, now blue. This one is the white, and this one is the silver. Okay, write down the resistance: green, blue, white, and silver. Now the next, there is only three bands, three ring. Okay, white, gray, orange. Okay, you have to write the resistance of this one. This will be the your homework. So two homework I have given. Okay, so this is the color coded carbon resistance, concept of color coded carbon resistance, my dear student. I hope that you are not confused while solving the question, the simple question of this one. There will be a different type of question also in your examination. I have given in assignment, my dear student. Okay, now in this lecture we will proceed for the resistance and the combination, the next topic. Okay, resistance and combination. Resistance and combination. Okay, so already we know, we have studied about the resistance. What is this? So the resistance is nothing but the obstacle offered by the charge carrier to the conductors in which the current is flowing. Okay, the symbol of resistance we will use like this one. This is the symbol. Okay, and unit, that is the SI unit, we use at this one, ohm. Okay, this will be the SI unit. Now the combination, we're directly going to find here the combination of resistor. So the first one, it is the series combination. I don't need to just waste my time to explain what does it mean the combination. Actually, we try to find out the one resistor or one device behalf of the number of device. Already we have studied in capacitor also. In same way, we'll find out the equivalent resistance in this segment. Suppose you are having two resistors. It is connected in series with a battery. Suppose R1 and R2, the battery voltage V. What you have to do, you have to convert this, or you have to find out the one resistor behalf of this one. But the condition what? You have to apply the same, you have to maintain the same voltage. If it is drawing the current I, then this will also draw the current I, and this could be considered the R equivalent, my dear student. What are the keys? So keys are, the current will be same in series as there was charge was same. Here the current will be same, but what will divide? Yes, the potential will divide, V by 2 and V by 2. Here current will be I, the total current, and the potential will be V, the total potential will be across this resistor. Now my dear students, if you will apply the Ohm's law individually on the three, then you will find for R1, V by 2 is equals to I R1. Okay, and for R2 you can write again V by 2 is equals to I R2, am I right? And for this R equivalent, you can write V is equals to I R equivalent. Now my dear student, we know that Here the voltage is dividing, that is V is equals to V1 plus V2. Now you can write here the V is equals to IR equivalent. IR equivalent equals to V1. What is the value of V1? So here the voltage will be V by 2, but we can write here the, if this is the voltage V1 and this is the voltage V2. Suppose if both the resistors are not identical, then it is not necessary the voltage will be V by 2 and V by 2. Suppose it is V1 and it is V2, then you can write this V1 and V2 as IR1 plus IR2. I will be cancelled out and then R equivalent will be R1 plus R2. Okay, R equivalent will be R1 plus R2. So equivalent resistance in series combination will be R1 plus R2, and for n resistor, identical resistor, R equivalent will be n times R. Already we have discussed in capacitor, that's why I'm not taking so much time while explaining this one. Now parallel combination, my dear student. Okay, we'll do the parallel combination. Even you can also do the parallel combination. This is not very difficult for you. Parallel combination. Suppose the two resistors you're having applied a battery, voltage V, here the R1, here the R2, the current I, but what will happen here? The current will change. Suppose I1 and I2. Okay, the voltage remains same, here the V and here the V, because both are in parallel. What we have to do, we have to obtain equivalent resistance behalf of this two, but this R equivalent should be maintained on the same potential and given the same current. Now my dear student, remember this actually I1 plus I2. Here current is breaking in two parts. This I is sum of the I1 plus I2. For R1, you can write for R1, here the voltage is V is equals to I1 R1, or I1 is equals to V by R1. Similarly, for R2, you can write here the V is equals to I2 R2, or I2 can be written as the V by R2. And for R equivalent, my dear student, you can write directly for R equivalent, you can write directly here the I is equals to V by R equivalent. Yes, yeah. Now you can put all these three equations in this one, and you will have like V by R equivalent is equals to V by R1 plus V by R2. V will be cancelled out, and then you will have the 1 by R equivalent equals to 1 by R1 plus 1 by R2. Okay, my dear student, that is R equivalent will be R1 R2 divided by R1 plus R2. For number of resistor, if n identical resistor, the n identical resistor will be connected, then R equivalent will be how much? It is R by n. Okay, and in series it was n times R, my dear student. So in this way you can see the resistance in parallel, it is decreasing, whereas in capacitor we saw that in parallel the capacitance were increasing. Okay, so this both are the reciprocal to each other, and this will be the easy to remember. Okay, the few question I'm giving you, my dear student, in next class you will show me this particular, or you can solve this one over here also. Let me wrap this one. The very simple question I'm giving you, my dear student. This is your classwork. You will show me. Now, the question is, you have to find four things. The first, R equivalent. The second, total current, I total of the network. Third, I across each resistor. And the fourth, voltage across each resistor. Okay, my dear student, and this one is the question 1. 5 ohm, 10 ohm, 5 ohm, and here the 40 volt battery connected. The second question, it is connected by a battery. Here the 6 ohm and the 3 ohm and the 20 volt battery is connected, and you have to find all the four things, okay, in both the question. What is the first R equivalent? The total current of the circuit, that is the current drawn by the battery, current drawn by the battery. The second, the I across each resistor, and voltage across each resistor. Okay, my dear students, so this is your homework, and we are concluding with this classwork, you can say. Okay, in next class we'll study the mixed combination. That will be the very fantastic class, my dear students. Thank you very much.